valve closes, the other end of it's closed. And I got to thinking about waveguides and whatnot. This thing is a waveguide. When both the valve and the piston are open, we have a certain fundamental frequency. When one or the other closes, the frequency goes up nearly 4 times. And I think that's in my paper. When that happens, based on the dimensions of this waveguide, we have microwave frequencies in operation on this water vapor. Microwave frequencies from a mechanical mechanism. It's absolutely incredible. So we get this water vapor in here and what happens when you microwave water? So we get a high potential expansion rate of the water going through this valve and driving this piston. So we've got 2 different drive mechanisms working on this little motor. So the guy was a genius. There's no doubt about it, and this was the machine he gave up on. He went on to better and more higher things that we're only now beginning to get any kind of idea about. Any questions on this motor, or the water phenomena, or the cavitation, or water hammer?
Can you fire it up?
No, it's not operational. It was about 2 years ago when I finally hit on the idea that it was water hammer. We did changed some of the pipes because they were all split and broken, and some of the joints were broken. We soldered those up. We put new gaskets in it, and we put it in a bathtub, and we ran a little bit of water into it. And it was kind of phenomenal what happened. The thing like it came alive. It just kind of, like it came alive. And but it didn't operate as we think it should operate. And we feel that's because of the timing mechanism in these valves. We don't understand those yet. So we really didn't know how to deal with those. And first and foremost is this is an original priceless antique. We didn't want to mess with it very much. Just enough to see if my idea was correct about the water hammer, which we did prove and verify. So eventually, if we ever get any money, we're going to exactly duplicate this thing, and then we can play with that model all we want to. Yeah, you had a question?
Raise your hand if you have a question so I can get it online. All right, go ahead.
What would it cost to produce one of those machines?
I think machinist time is about between $30 and $60 an hour. It would take a lot of money. It would take several thousands of dollars, just machine work, to duplicate it. Now, another idea is once we know the principles and how this thing works, we can design our own from scratch using electronic valves, so we get rid of the friction phenomena and all that kind of stuff. And I think we do understand it enough to design our own from scratch. And I do have some designs that I've worked with. I've got various devices that I've been working on the designs of that we may be able to build. Yes, sir.
Have you heard of the 300-mile an hour submarine? A gentleman, I believe it was in the 50s, built one as a one-man submarine. He crossed the Atlantic Ocean in about 24 hours, something like that. But I think he was using a turbine. But a turbine could be set up to use the cavitation principle. Each blade of the turbine would be making a cavitation.
Okay. That's a very good question. No, I haven't heard of that particular machine or that event. Using turbines is very interesting because the Tesla turbine, for instance, where you have the smooth disc, I have a model of it over on the workbench over there, on the book table. When it draws water in, if the velocity of that draw exceeds a certain point, the water cavitates, and it will cease to draw. Any pump will do that, can create that phenomenon. So you can only draw water in at a certain given velocity. However, I believe the same thing happens with air and jet engines. They can cavitate and they'll flame out and all that kind of stuff. But any fluid will do that. So certain designs, like the Schauberger material, seem to indicate that we can supersede, we can increase that ability, or we can push back that threshold of cavitation to a great extent and thereby increase velocities and attain those things that you're referring to. I believe Keeley was doing some of that work too. Although there is another way of how do you call it, propelling a craft or a mechanism that is not male-oriented. And we can get into that too. Remind me of that, and we'll cross into that. You have a question?
Yeah, the opposing counterweights, what do they do? Is it perhaps that one motor goes for a while and then the other side goes where those counterweights come up and down?
That's part of the question we haven't answered in this particular design. We know that this weight maintains a pressure against this piston. This is what maintains the pressure within this cylinder, so that when this valve opens, it has that velocity to the water stream. This one over here maintains this piston closed. So when the water ejects against it, there's a certain resistance to the water stream. And I thought, well, why couldn't we use spring-loaded mechanism instead of these weights? And there is a different reaction to these weights coming down as opposed to a spring mechanism. And also in the 1880s, they didn't have the materials we got today, so you probably couldn't build a good spring like we can today. So there's many different questions. We don't have them all answered. You know, we've got the basic phenomena figured out, but why did he do this and do that and not the other thing, we can only conjecture. And the timing, each cylinder has its own timing, and how they work, plus the timing in the timing gears.
Comment on the spring. The acceleration from a spring is totally different from the acceleration of a released weight. So you wouldn't get an instantaneous switch or as rapid a switch. It would be a more gradual switch. So a spring would have a totally different mechanical phenomenology. And if you're opening and closing a valve, that's probably the best way.
Yeah, I agree with that. That's kind of what I came up with. I had built a model of this cylinder, and I used a spring because I didn't want to build all this mechanical stuff, just to prove that I could capture pressure with water hammer, and it did do that. So we can do those things. And I think if we had more engineering expertise working on this problem, we'd come up with all kinds of solutions to it.
Yeah, Dale, you said that you'd only found 2 books on cavitation.
Right.
Do you think the level of knowledge in physics right now is sufficient for you to be able to model the cavitation effect of this machine, say?
Yeah.
For example, you think that the theoretical development in physics, the level is high enough right now? All the concepts that we need to involve here present in physics sufficiently that we might be able to mathematically model this machine?
Easily.
You think so?
Easily, yeah. What goes on in here, once you start to model it, is real simple. It is echoes of shock waves and things like that. We know a lot about shock waves.
About shock waves, yeah.
And water hammer is a study of these shock waves within a given mechanism, you know, water pipes. So that's where the breakdown occurs, is when you try and take the mathematical formula for water hammer and apply it to this engine. Well, it starts breaking down because those are designed for water tubing and piping and whatnot, and this isn't. So we've got to modify them to a certain degree to bring them into coincidence with what goes on here. But I do not think that what is happening here is beyond our current technology. Now, this negative attraction stuff is beyond our current technology.
Negative attraction. Could you explain that a little more, to negative attraction?
Well, I got to give you some basics first. We'll go through some basics. We can leave this for now. We can come back to it. Anybody got any questions? We can come back to it. We're going to do some other things. The universe is a musical construct. Everything in the universe vibrates. Everything. There is nothing that does not vibrate. So we can almost say that there is nothing in the universe except vibration. Centralized and decentralized vibration, or polarized and depolarized vibration. That's what causes particles to come together and to go apart. And we're going to go right into all these details of how this is done according to Keely's philosophy, which we find out is not that much divergent from modern philosophy. This guy did all this work over 100 years ago. The electron, by the way, was officially recognized in 1893. I think it was Rutherford who got the credit for that. All of this that I'm going to show you now precedes that by at least 10 years and sometimes 20 years. First thing I want to show you, is what is a vibration. We talk about vibration, we